The topic is about automotive ECU. Here ECU is electronic control unit. It is a fundamental component in a modern vehicle. It is symbolized for controlling a range of functions within the vehicle, electrical and electronic system. The ECU is essentially a small computer that uses a sensor and process the software to monitor and control the specific parts of vehicle. This technology has become essential as a vehicle have evolved in more complex system requires precise control for optimizing the performance, safety, and efficiency. The ECU is the embedded system in automotive application, commonly referred as the vehicle brain. It performs tasks as controlling the engine function, monitoring the engine sensors and the actuators. To make the sensors and actuators to respond within the time and to activate the functionalities, it requires internally sub-functions, the components to develop the software and to make the testing of those sensors and actuators. Internally, we require some of the protocols for debugging purpose, and eventually it has some of the sensors that able to configure specific to the ECU, which essentially required for flashing the software and for debugging the software and the saving of the data in the memories, the NVRAM memories. Those are the essentially the components. It will be a part of the application of the microcontroller. So here it have the processing. Processing is the one which access the data from the different sensors and processing. So here the processor plays the major role to process the data from the inputs and the outputs. To understand the architecture of the ECU, the hardware components, microcontroller, as we know, it is a brain of the ECU that execute the software instructions, and memory, we have the flash for storing the firmware, and RAM for runtime operation, and EEPROM, it will persist the data configuration. And communication interfaces, the CAN, LIN, FlexRay, Ethernet, SP are the some of the other protocols that used for configuring of the ECUs to communicate the data between the devices. Power supply is essentially it required for the microcontroller here, the ECU. It is it will be varied the ranges for 12 volts, 24 volts, 48 volts, depends upon the application of the ECU that we are configuring it. And coming to the software components, it have the application layer where the specific algorithms can be written and to perform the specific functions operations in it. And midway, it is the interface between the application and the hardware. The main, it is a part of a RTE, the runtime environment. It will play major role between the application and the hardware abstraction layer. And real-time operating system, RTOS, where we need to ensure that the scheduling or the algorithms and the time scheduling is the one which will play major role. And some of the critical applications we use the real-time operating system. And what is the ECU here? ECU is the embedded system. It is a combination of the hardware and software that control the specific automotive application. So in the block diagram, if you see here, we have the inputs where it will have the throttle position sensor, coolant temperature sensor, and mass airflow sensor, and crankshaft position sensor, and air fuel sensor, and barometric sensor. So those are the inputs that we are providing to the ECU, and the ECU will respond. Here the ECU is the microcontroller. It will take these inputs and it will process the outputs, the time of the fuel injection, specific to the air and the fuel. And next we have the evap solenoid, evap and the EGR valve, and fuel pump, and ignition control module, and throttle body. So those are the essential output components that we configure to the hardware. And what it will do, it will collect the ECU will it will collect the data from the sensor and processing it, and it will send the commands to the actuator to achieve the desired operation. What specifically the automotive ECU is? The specifically the automotive is ECU is it about the it is a brain of the car electronic system. It is a small computer that manages controls or one or more in the vehicle system, and it is a specialized computer system designed for specific tasks within the large cars, and it will manage the software, the inputs and outputs configuration with respect to the hardware and the software. And here the ECU is a critical component in the modern vehicle. So it is responsible for managing the various functions and subsystems. Subsystems like ADAS, the ADAS driver assistance system, infotainment, and there are some part of autonomous driving capabilities, the braking related or the steering related. So those will be a part of the autonomous driving capabilities, and it able to activate those features. It should have different ECUs and different components will be played major role towards the hardware and software, and it covers how the ECU works, and it if any fault is occur during that, what is the necessary steps you should take, and how should be how the fault can be recovered, can be happen, and that can be suddenly like whenever the vehicle is going, that there is a fault is occurred in the part of the road or off-road or on-road. So how that can be triggered, and how the vehicle can be managed well towards the steering or the braking in any part of the fault triggering. So what happens if a ECU is dead? The car won't start at all. The ECU controls the engine ignition, so the dead one will not start the car at all. Other function will not work, but if the engine is is not able to start properly, then the alternative way is to make the vehicle to smoothly drive, or to the without with respect to the battery without engine. So how that efficiency will maintain, or such are the advanced features that emerging into the automotive domain. So why electronic components in a vehicle? So mostly, like as we know, the ECU is a combination of the inputs and outputs. Here we have the temperature sensor, pressure sensors, and some of the inputs we are giving to the ECU, and outputs are the uh, actuators or the solenoids or the motors, which makes to operate. So it is a electronic device. So where the number of signals are configured, and for the number of signals with respect to the sensors or the inputs, that it have specifically mapped to the memory, and it will it have the specific operation and specific algorithm will be configured to the pressure sensor or the temperature sensor. Based upon that, the input will be triggered, uh, and the output can act on the based upon the software that it is configured. So whenever the sensor is not responding properly, then in that case the output, it may create a faulty, so that faulty can make the system to be disturbed, and it created the big issue within the ECU. And how it works. So sensor ECU receives the input from various sensors located throughout the vehicle, such as engine temperature, wheel temperature, oxygen related level during the exhaust, and pedal position and data. So once the sensor gives the data, it will be processed. So here the ECU takes the data from the sensor and process it towards the software and algorithm. And the actuator, it based upon the data process, the ECU sends the data to the actuator. Actuators are the devices that make physical changes to the vehicle system, such as adjusting the fuel injector or controlling the transmission, applying the brakes. So what is the electronic sensor? So electronic sensor is a device that detects the physical parameter of the parameters like heat, light, or sound. So, which converts this electrical signal to the specific value by using the electrical or electronic system. So, with respect to the software or the wiring communication. So, here the sensor is it will sense the information based upon the physical phenomenon the output will be getting from it. What are the different types of sensors? The temperature sensor, it will monitor the engine and exhaust and cabin temperature. It's specific to the safe and efficient operation. And the pressure sensor, the fuel, air, oil, so system to monitor the pressure levels, and even it comes a part of the TPMS, tire pressure monitoring system. So those are example. And oxygen sensors. So it will measure the oxygen level in the exhaust gas to optimize the fuel consumption. And radar and lidar sensors. It is for ADAS, autonomous driving assistance system. So where it will read the information from the surrounding vehicles. And the position sensor, it will measure the position of the moving components like the crankshaft, camshaft, and throttle. And IMU is the inertial measurement unit. It is used in the vehicle stability control. ADAS system to measure the vehicle motion and orientation. Car actuators converts the electrical signal from the ECU into the physical action. So here the fuel injectors, they are controlled by the ECU to precise where it will play the injection of the fuel on the combustion chamber, and throttle actuator, so where it will control the air take into the engine, and it will process the accurate fuel during the combustion. And next is electrical motor. It is used in various components like the power windows, wipers, and power seats. And the solenoids are used for the automatic transmission to control the flow of hydraulic fluid and manage a gear shift. And to communicate all those sensors and actuators, we require the wiring harness. Wiring harness is the nervous system of the vehicle where it converts the various components, ECUs, sensors, actuators. It will allow for the data to flow and the power transmission. It will be having a low voltage wiring. It will be optimally operated with 5 volts to 12 volts, and high voltage it can be operate up to 400 volts. And the CAN bus wiring, it carries the signal between various ECUs, where the CAN protocol is also a part of the communication protocol between the data ECUs, where it will exchange the data between the one component to the other component. Why ECUs are important? Because it will improve the performance, it will optimize the engine performance and fuel efficiency and the emission, and it will be the enhanced safety. So towards the ABS or ESC and airbags, it increases the comfort. It manages the climate control, infotainment, other comfort features. Great, and it will help the greater efficiency. It will towards the fuel consumption and part of the. And what are the types of ECUs? So generally the ECUs are engine control unit and transmission control unit and anti-lock brake system ABS and airbag control unit and body control modules. So these are some examples of the ECUs that are adopted in current vehicles. And the ECUs, it have different components and different sizes that will be placed in the vehicle. Engine ECU, head unit, instrument cluster, driver seat control, body ECU, keyless entry ECU, data link, rear view camera, side obstruction detection ECU, telematics box, parking head module, driver door control, TPMS ECU, restraint control ECU. So these are the some of the examples of the ECUs where it is essential for the vehicles to manage the data and to protect the passengers or the drivers in the vehicle and the comfort of the passengers and the driver seats. To communicate all those the ECUs, we require the protocols. The protocols are operated based upon the communication architecture. Some of the engine and transmission issues, it required CAN-FD and FlexRay protocol, and some of the body and comfort futures ECUs, it required LIN and CAN for door locks, climate control, seat belt, and sunroof. And FlexRay, it will be operated for some of the ECUs specific to the chassis. So it's they have a different configuration with respect to the different ECUs where the protocols will be operated. And examples of the powertrain control ECU, engine control unit and transmission control unit and hybrid control unit are the powertrain control ECUs, where the ECUs are played a major role towards the transmitting transmitting of the power to the wheels. So from the engine to transmission and drive shaft and differential and rear axles, like here we have the right and left axles. So to ensure that the transmission is happening efficiently. And the chassis and vehicle dynamics are the major role towards drive on the vehicle. Here it have the braking control is a specific one, and the other part is the suspension. Suspension plays major role here, and it have the coordinates. Based upon the coordinates, the vehicle center force will be acted. So the vehicle system, it should have the proper center force to stabilize the balance during the driving. And these are the chassis vehicle dynamics where it will support the braking and suspension related. So it required essential data that will be transferred among the different ECUs. Next, coming to the ADAS and autonomous ECUs. Autonomous driving, so it's required more sensors and towards the vehicle, and it plays a major role to capture the different sensors data and fusing those data and decide how that circumstance can be occurred and how to avoid that circumstance incidents. So that will be decided based upon the different sensors surrounding the body of the vehicle, and it will be decided and it will take the priority. So where the camera and radar and lidar ECUs are the one, it will support more. And next we have the camera and ultrasonic sensors or the other sensors. It will support for the parking and part of driving purpose. And infotainment ECUs, we have the head unit ECU and MDU, and we have the other part of ECUs like telematic control unit and climate control related data that can be monitored also in the infotainment ECU. So these are some specific ECUs, and additional ECUs are added for the infotainment ECUs to ensure that the data can be monitored and tracked the information of the complete vehicle system in this ECU. And we have a body control model. The body control model is a BCM model. Here it has the wiper and the control lights, interior and exterior lighting. And next we have the HVAC, heat ventilator air control module. So how specifically the interior and exterior can be managed, it will be handled by the body control modules. Here it have different issues, like we are focused to know more on the climate control ECUs and the body controller, wiper and the windows ECUs. And the comfort and safety are essentially responsible for monitoring and controlling and executing the critical vehicle safety features, where the passengers can be protected during the emergency situation. They are like before accident or after the accident, how the passengers can be protected with all the journals. So here the telematics also plays major role. It have the specific ECU. It is a wireless communication between the different ECUs, and it have wired communication with respect to the internal ECUs that configured in the vehicle, and a GPS to know the exact location of the vehicle, and the protocols are configured to the other ECUs. And it have a telematic is a gateway ECU, so it requires some security features to ensure that efficient data can be transferred with respect to the ECUs. And we have the specifically the gyroscope or accelerometer and magnetometer. So how that can be managed the vehicle positions. And we have the connecting to the environment, like we have a V2X, the infotainment or the telematics or V2X. Under that we have different models. Similarly, we have a GP telematics, we have different models, and infotainment, we have a different models, head display in it, audio, Wi-Fi, or some part of the different features it have. And what are the key functions of the ECU? Mainly the data acquisition. It will connect data from the sensors and temperature sensors. And next will be a part of the processing, how the data can be processed with respect to the algorithm, and the acquisition. So once the data is acquired from those different sensors, then that will be processed. Based upon that, the actuator will say, perform some action. And diagnostics, whenever the failure is happened in the within the vehicle, so that can be identified, and that can be solved within the vehicle or wired or wireless. Like it's a part of the vehicle configuration protocols in it. And if it is a physical level fault, that can be identified and fixed it. So with respect to the diagnostics, and that how that can be developed and tested for testing can be performed in the ECUs. So development process where we work for the requirement analysis. So we need to understand vehicle level about the requirement and the ECU, and that can be configured with respect to the model MATLAB Simulink. And once that is available, that will be converted. Model is converted into the code level, and once that is code is code is generated, then it will be integrated with the hardware and software, and we used to perform that validation. So it will be a part of whether specifically the requirement is developed and it is performed well or not, so that can be verified. It is a part of the system process towards the ECU, how we are able to develop it. And testing, so specific to the ECUs, we can perform unit level testing, hill level testing, and vehicle level testing. And what are the real-time challenges in the ECUs? The real-time challenges, it will be the complexity and the software growth, because the modern vehicles have 100 plus ECUs, each running millions of lines of code, and managing the complexity. We need to ensure that software quality is a major hurdle. And real-time processing, ECU must process the data and execute the control functions within the strict timing constraints. For the AB braking related or the airbags related, it will be the time critical. And meeting the critical safety features, it will be the one more challenges. And safety and reliability, so ECUs are responsible for critical functions towards the braking and steering and airbags. If any failure is identified during the development or testing phases, so that should be fixed, because the real-time vehicles, it will be difficult. And the security, it increases the connectivity, makes the vehicle vulnerable to cyber attack. Protecting our ECU with the unauthorized access or unauthorized softwares is essential. And we have power consumption. ECU must operate the optimally within the vehicle power constraint. It need to manage with a reasonable voltages for the specific functions. And testing and validation. So all the ECUs electronic components should be go with the functional safety standards ISO 26262. So it should meet whatever the software that we develop and we tested. It should meet the functional safety standards. And next is the over the air. So the auto updates, where it will manage the secure and reliable auto updates without disturbing the vehicle functionality. And hardware limitation, ECUs offer have the limited processing power and memory. It will optimize the software for the constraints while meeting the real-time requirements. And integration, it is a integration of the software from the different suppliers, and the ECUs. It have been complicated, complexly increases in the vehicles, so that should be optimized. And the cost, the development and validation of ECUs is expensive. So both balancing the performance and safety features with respect to the constant is a way, important. And thermal management, ECU operate in a harsh environment, ensuring that the ECUs cannot be heated up for long run. It should be cooled it up in different climatic conditions. And obsolescence is, so designing the ECU with enough flexibility accommodate those feature updates and avoid the obsolescence is important. And talent storage, finding and retaining the quality engineers for complex ECU software development is challenging. So those are some challenges. And what are the future trends in ECUs? The future trends in the ECUs are domain controllers, centralized architecture, moving of the numerous individual ECUs to the fewer and more power domain control for integrating the functionality and reduce the complexity. And the software-defined vehicles, software becoming a different tier with a flexible, where we need to upgrade the ECUs, enable the new features and new functionalities via the software updates. And virtualization, running the multiple software applications on a single ECU, that increases the efficiency and reducing the hardware needs. And next, increases the power, increases the processing power and the memory. So ECU gains significantly more processing power and memory to handle the massive data from the sensors and the cameras and some of the other sensors involved in the ADAS and autonomous driving vehicles. Advanced connectivity, so the water ECU increase the connectivity to each other and outside the world, enabling the water feature updates and remote diagnostic and connect the car services. And enhancing the cyber security. So here the security features are very essential for the ECUs, encrypting or the authentication or to if any hackers are able to track the ECUs, it should be identified and it would be protect from the hackers. And the AI machine learning, so it will be a part of the advanced features where the problem can be identified and notify the driver during the driving. And functional safety and reliability, so it's all the more advanced features towards the vehicle, how we are able to solve the problem and identify the problem is essential for the drivers. And next we have the thermal management. So if any issues are heating up during the driving conditions, so how that heat can be reduced. So it is a part of a challenging keyword, thermal management, and similarly how that can be avoided in the future. So it has specific controllers where it will be configured to work on those models. And these are the wire connectors to where specific problem is identified with respect to the pin naming that can be identified and fixed with respect to the wires that given to the ECUs. And to understand about the other components, the fuses, it will be having this in the vehicle, and we have a jumpers. Connectors are the configuring to the ECU and harness. So similar to this, the connectors are given to the group of wires. It will be harness and power distribution. So just to understand the power we are distributing to the component. Here the component is the hardware and which have the inputs and outputs. And what is the automotive car variants? The variants are nothing but the different versions of the same car model. It's offering the various levels of features, equipments, and sometimes the performance. And here it belongs to the same family member, but it will be different in the variants. So trim level, so interior and exterior and technology wise, safety wise, it will be varied. And the engine options, it will be like the diesel or petrol or hybrid, so that can be differ. and transmission option, like whether it's the manual or automation. So it all a part of the variants. And next optional packages will be there, the safety features and the special editions. So that based upon this, the variants will be decided. Why car makers offer the variant? Because it have a different budgets, but different prices, and based upon the prices, the features will be added, and that based upon the features, so the car specific operations will be performed. So it have a different options to choose which variant we need it. And choosing, like you need to need what is the priority, what is the need, whether you need a manual or automation, such automatic car transmission. So that should be decided. Based upon that, you need to decide which variant you should go for. So specifically, if you see, there are different variants. This all belongs to the one family, and it have a different variants: convertible and couple and electric, hatchback and microcar and minivan and MPV, sedan, SUV, truck, van, and wagon. These are the different types of variants which are available to drive the vehicle. And automotive OEMs, OEMs stand for original equipment manufacturer in the automotive industry. It refers the companies that manufacturers are the part or component that used in assembling of the new vehicles. So what it means exactly? Original equipments are the part of the originally installed vehicles. It is the first build in the factory. Manufacturers are the company that produce those parts. What automotive OEMs do? They will design and develop and produce the vehicles. So specific to the components: engine and transmission, electrical system, bakery system, and the suspension system, interior and exterior components. So those are the components they will assemble, and they will design. And the relation between with the car manufacturer, because OEMs are the Ford or Toyota, BMW or Benz. There are some of the OEMs manufacturer, they will design the cars. And the important part is the OEMs have the have the dealership